Okay, so firstly, whenever you guys log into the app, a little, hey, connect here will pop up. The app on iPhone or iPad is a free version, but to save it is paid. So just type in the credentials and hit connect, and you won't be able to automatically pick that in again. But I'll send out this PowerPoint along with a Zoom recording at the end, so you guys will be able to log back into that. That login information is generic for everyone, so it should be good as long as Professor Gwynn keeps it up. So the iPad, iPhone is at the top, and your workbench is at the bottom. So again, that's going to stay on here while I talk about a little bit of SQL. It will change slides. There we go. Okay, let's talk about a little bit of SQL basics. What does it stand for? I mean, yes, it's an acronym, SQL, but nobody calls it SQL. Don't do that in a job interview. You're going to look really silly. It's SQL. We all call it SQL. It's structured query language, right? It is used specifically for communicating with databases and performing certain tasks in there. So unlike your Pythons or Javas or R's, where you can like develop whole applications and graphical user interfaces, it's not really the intent of SQL. It's much more simple than that, which is great because it means it's really easy to learn and it's very standardized. So there's lots of different platforms that use SQL. You have Oracle, you have MySQL, you have Microsoft SQL, a bunch of them. But throughout all of those, it's very similar structure. So you learn one, you got it for the rest. You'll be able to do at least basic stuff. And if you need a chat GPT, hey, what's this conversion for a certain keyword in one or the other? Not a big deal. So, and it's also a very essential skill. Doesn't matter what you're in. Even if you're not in the business school, you'll probably come across some form of SQL in your career at some point. So do you need to remember the exact structure of the queries that we go over today? No, that's not super important. But remember kind of how it works, how think of those objects in your mind is really going to help you whenever you come across data, and whether or not you're actually the one building databases. You may not be, but you're going to be using that data. You're going to be having reports sent to you. You may be making reports on your own. Understanding how it got to that point, once it got to your desk, that then you do a little more work with is super important. So in order to understand SQL, we must understand a little bit about databases, right? If we're going to be communicating with databases, we have to know what a database is. So what is data? It's just simply facts or figures. That's all it is. And when we say like one piece of data, because it's a plural of itself, we just mean like the number 32, or the word Jim, or the date. So we can think of data, right? There's no context here. The number 30, 32, what? Jim who? What's his date? What does that apply to? We don't know, because it's just raw. There is no context. There is no additional attributes to that. So you can think of this as just a single cell in that Excel file. You just type in a number there. Okay, cool. That's a piece of data, though. Or my favorite example is a Lego piece. So I grew up with Legos, but I did not grow up with the fancy smanchy kits. I grew up with a big old bucket of Legos. So we can kind of think of just raw data as a bucket of Legos. That's super messy. Try to analyze that, try to make any meaning or sense of that on its own how it is. We can't. We have to give it some structure, right? Usually we would thump on the floor, right? And we make maybe two big groups or something, and maybe we go into bigger colors, maybe shapes, sizes, something like that. And so that's the same thing that we do in the database. Data comes out raw, we don't know what it is, and we're going to start grouping it. And we're going to make big groups, then smaller groups, even smaller groups, all the way down to a single brick. So we got everything in its own individual group for each individual piece of data. And we call that a schema. The schema provides that structure. We define that sorting. We defined that this brick is a number, and it is, maybe has no decimal. We define that Jim is a word. We define that October 19th is a date. We give it all of that, and we say, hey, everything in this group has to follow that same schema, that same pattern. And it allows us to get it to that data very efficiently. I can say, hey, I only want numbers. Now I've filtered out a lot of that data, or only want a certain group of data. We'll go through how schemas do this very soon here. But the most basic form of a schema, conceptually how you think of it, is it assigns each brick an address. And this is what that address looks like. So very high level. We'll go through this address. We're going to break it down here. But through this address, we can get to one brick. We can query this database using the language of SQL to say, hey, give me this one brick or collection of bricks belonging to different groups at different levels. It's a hierarchy. So everything is going to be in a server, right? So we can think of it as kind of like your street address. So let's write that down. So the server, right? Well, when we connected to that database, we put in the server name bigdata2.gwin.net, right? So that means in all of the internet, of all the servers out there, that points to a unique identifier, to exactly Professor Gwyn's database, Big Data 2, not to anyone else's. So that's the highest level. It's like, think of the universe. We're on planet Earth. Cool. That's pretty easy. We started at the biggest level. We got down to one level further. But how often, when putting in an address, do you have to say, yeah, I live on planet Earth? Well, for now, you don't have to. Once we colonize Mars, you may. But for now, we don't. It's kind of implied, right? So by connecting to the database, we told it that, hey, every time I put a query, whenever I'm in this connection, go to the server. I don't have to specify it again. It's smart enough to know that. And because we also put in there the DB or database name of DL training, we don't have to specify the next level either of database. But a server, right, can have many databases, right? The universe has many planets, and many planets have many countries. There we go. We're getting to your address. So we already specified, sometimes you don't have to say you're in the United States. We already specified, hey, we're in this database. So again, I don't need to specify, but if we wanted to, we could say, hey, use a very specific one. if we left that blank. Okay, now we're getting down to the schema, and you're probably giving me weird looks. Evan, you already said the schema is the structure. So why is the schema part of itself? Well, the geniuses who named this did not think about this, I think. This is a different schema. We can think about this as the logical container schema. So from now on, I'm gonna do my best that if I refer to the database schema, which is that overall grouping, structure, and addressing, as a database blueprint or framework. Some people in the industry do call it this way because it is confusing. In this level, the schema here is really for security. If you ever get into databases, you'll learn how each one of these levels has some unique properties that is associated with it. So this schema is very heavily focused on security. If I want to give you access to my database, I may limit you to just one schema, and you can't see or access anything beyond that. So because of that, whenever we're querying data, we just want to access it. You don't really need to specify the schema. We do have to tell it, hey, which one it is, because tables can have the same name across different schemas. So we have to specify which table we're talking about. There's 2 customers tables within that database, and we have access to both of them. But we're going to query them together. And we're going to use that with what's called a from clause. So we're saying, hey, well, I want data from this specific table. Yes, schema.tables. Okay, what about the column? We're getting pretty close to getting to that one Lego brick. How do I specify which column I want, right? This is just another group, except for we just structured it. Think about those Excel spreadsheets. It's that top row, the columns. So we just placed it on the top. How do I say which one I want? Well, weirdly enough, we're going to say that before the from statement. As we'll get into a little bit later in the demo, if I want to say multiple tables, I don't want to have multiple select statements. So I'm just going to say one select statement for all the tables I want. So we're going to put that at the very beginning. And then I can put down all the tables I want right after that to make it a little more clean, a little more easy to organize. But it's a little weird that that level is before the table level. And lastly, the row level. How do I specify which rows I want? Well, we're going to use a where statement. The where clause specifically says, hey, I'm going to filter that table down to a certain number of rows. So through a very basic query, just like this, just select from and where, provided we already did the connection string, we can get a single piece of data or groups of data. We can get large amounts of data. Let's get through the demo. Last thing to remember here is that the order is important. We went select first, then from, then where. SQL expects these keywords to appear in this order, and if you don't, it's not sure what you're talking about. That's kind of that structure part a bit. You probably saw this screen here, just overview. Hop over to my queries real quickly. That's where we're going to go ahead and start. And then hit the plus button at the top. And by default, it's going to kind of set up those basic parts. Every query is going to have a selection from statement, so there's no reason you have to type it every time. It's going to throw it in there for you. And probably think to yourself, Evan, what the heck is this asterisk after the select statement? What does that mean? Well, we're going to call it a star in the programming world. We'd like to shorten everything if we can. So it's a wild card. It says, hey, give me everything that you can within the current context. If I just run this, it's not going to give me every column in the database. It's going to require that I specify at least one table. But whenever I do specify a table, let's just pick the one at the very top there. It says classic models.customers. So that classic models part is the schema. The .customers, that's the table. You can just click it. And it'll fill it in right away. So, okay, let's take a second here. Let's take a look at that. I'm going to press done. I don't really care about saving it because we did barely nothing. But if you go down here to the bottom, look at the table/views, it's actually organized it for us in those middle 3 layers of that address. So we have the schema. It's specified, hey, schema is classic models. Within that group, there are 8 tables. Within each of those tables, here are the columns. Right, and then I think this at the very end is the row count as well. So we get a lot of information, but we don't see the actual data yet. We don't see any bricks. There's no bricks here yet, but all that schema, that definition is surrounding it. That's what we're looking at right now. And a lot of times, I mean, your data is going to change, right? 32 may be 32 years, and next year it'll be 33 years. So the data is going to change, but your schema you want to stay much more consistent. So unless you go in there and manually change your schema, that's not going to change. The data in it may, the schema won't. I'm gonna hop back over here to my queries. Okay, so let's go ahead and run that. And you can hit by the execute or this little lightning bolt at the top, and it'll pop up a cool little table. And if you're on an iPhone, it'll just take over your whole screen. But that's okay. You hit done and go back to your query. Look at that. Now we're seeing data. Pretty exciting, right? We can see we have a customer number, the name, last name, et cetera, et cetera. So we've applied the schema here as well. The schema addressing, right, for each like individual field, this field, signal gift stores. We've applied wildcards. So we said, always set the server in the database, specify the schema in the table. We've given all columns. So we can now see that this is one of those columns. This is one of those rows. We found the address. And just like you can see, row numbers are just called indexing, right? Because your data may change, right? That all the data points in that row may change, but then keep that index. So that's how we can also specify the row. But typically we won't. Typically we'll put some other condition on it. So let's give that a try, right? Because ultimately I don't want row 5. I don't know what row 5 is yet. I mean, we can look at it, but row 5 will change. So maybe I want something more intentional, right? Maybe I'm someone who's looking at the customer database and I want to market to my customers, but I want to market a wealthy product. So I want to look for customers that have a pretty high credit limit. If we pop all the way over here, we can see at the last column is credit limit. So I don't want to spend $1 million marketing to people who can't really afford my high-end product. So I'm going to filter this table down. I'm going to remove some of the rows and only get the customer rows where, look at that, that's that keyword, where the credit limit is more than $1,000. That's how easy SQL is. That we're going to put that in exactly. So where is the keyword? I'm going to find the credit limit field. If you're on your iPhone and you click that arrow right next to that customer table, it'll pop up the fields for you. So we can just key them in, and we'll scroll all the way down to the bottom and find credit limit. So filled it in for me, right? So I said where this column here, and I want it to be more than. So more than, the operator is just the more than sign. And then $100,000. That's it. That's as easy it is to filter down your data. Hit that execute, hide my screen here, and now we're only down to 25 rows. And I can verify that by looking at the data, scrolling all the way to the credit limit and seeing that, in fact, all those values are more than $100,000. So we had this column called customer number in the orders table, and an identical one called customer number in the customer table. These two obviously have a relationship together. We call those keys, right? They're unique identifiers. Now, the important part here, and you see down here, primary key, is in one of those tables, a key must be a primary key. There's a few qualifiers for these, but know that the most important one is that it is unique within that table. Each individual row must have a different key. Pretty easy in the customers table. If you take a look, it starts, I think, at like 1,000 or 1,001, and it just increments by one all the way to the bottom. Keys will always be unique in order for it to match correctly for how we wanted it to be intended to be matched. Now, how do we actually bring this into our query? How do we say, hey, bring to me also from the orders table, bring on to me the customers table and match it with that key? So right in between our from and where clauses in our SQL statement, we're going to insert a left join. I'm not going to go into different types of joins today. Lefts are the most common, 99% or something is going to be a left. So we're going to say left join. That means we have the orders table here on the right, and we're going to add on to the left customer table, right? And we're going to specify, hey, customers. And we need to specify on what field. It doesn't know. By nature, it could be any of those fields. So we're going to tell it, give it to me the customer's customer ID table and the order table's customer ID. And then we can continue on with other row conditions, right? And this is why we have the select statement here at the top, because I can select star from both orders and customers. I don't need to say select star from orders and then again select star from customers. I can say it only once. And whenever you start adding on more and more and more tables, you don't want to have to repeat that as well. So select is specified once, and the star is going to give it for anything within the list of tables that I have. So we want to know the orders where it's not shipped, and then give me the customers to it. I don't want all the customers and then the representative orders, right? I could swap it around and say, give me customers and then their associated orders. But no, we want it the other way. We only want a certain subset of orders, and we only want the customers related to it. Of course, we always start with select. Am I going to say select star? Because I want to see all my data. Oh, you know what? You can. That would be a lot of data, right? We already know the data of the customers and orders table. So this time I'm actually just going to say, hey, give me just the columns I'm really interested in, right? So back over here on that table tab where I open up the other fields, I can click on those fields and it will start selecting me just those fields. I won't get all the ones I don't want. So from the orders table, let's see here. I probably just want order number. Now here's the tricky thing, right? I can't just click another one. I got to put a comma in between it to let it know, hey, next column coming. So after customer number or after order number, I don't care about the dates. I do care about the status, right? Because we want to say, hey, the status is only where it's not shipped. I'm curious what customers are having orders that aren't being shipped. What's going on there? And maybe I also want customer number. Then from the customers table, I need to select my fields from there as well. I'm not going to click customer number. I don't need to. It's going to go ahead and do it all behind the scenes. It's going to find all of them for me, generate that result, and then it will filter it down. So I don't need to say customer number again. It's not going to affect the query. It's only going to affect if that column is returned to me or not. So instead, I'm just going to say, hey, give me that customer name. Maybe that first name and last name as well. If you look at the customers table, the name is like the business name, not their name, which is confusing. And you feel free to click any other column you want, but I'm going to leave it right there. You can add any other column as you wish, but that's enough. We don't need to end it with anything. Just do a new line and we'll say from. What's the first table? We're curious about the orders, right? We want customer information based off of the orders, but we're going to start with our orders. Here comes that left join part. Left space join. What's the table we want to join on? Customers. Okay. Remember in that PowerPoint slide, I said you have to say on and then specify both columns. Be kind of a pain to type the schema table name again within the column name, right? That would be a very lengthy query. So here's a fun little tidbit to shorten queries. Go right after the orders table, make sure there's a space there, and just put a letter. I put O, right? Orders table, so O. And after that customers table down here in that join statement, make sure there's a space. I'm gonna put C, put any letter or any number of letters as you wish. And what you're telling SQL here is it's picking up right? Because it's very structured, because it expects things in a very specific order. We don't have to go super detailed like we would in Python and specify what this all means. It knows that any letter following a table name or any object is an alias, right? It's just like saying a variable and saying equal to that object. Now, whenever I go and type that O again, it's going to refer back to the entire classic models orders table. So that's going to save me a lot of time instead of typing in classic model orders. I can just put in an O. And we're going to see that right now. Left join this table, customers. And we're going to say on. That's where we specify what are the two columns that are matching, that have the same data type, and whenever they have exactly the same value, I want those rows from the customers table. It does not matter if you start with orders or customers, as long as they are both in there. C dot, and find for me that customer number field. So instead of writing classic models.customer, I just wrote C. Much easier, right? Much cleaner and easier to read. And I'm gonna say, hey, you're joining whenever that customer number is the same, equals order table dot customer number. I'll slide that over here, see it a little bit cleaner. Now, if I run this as it is, right, I didn't put a where statement. That's okay. You don't have to put a where statement. It's kind of like the inverse of a select statement. You have to say select, even if it's select star, give me everything. The where is like the inverse. You only need to put where if you want there to be a filter. Whenever we're writing code, if we just write our entire code exactly how we want to play out and press run, it's probably not going to work, and it's going to be really hard to figure out why it's not working. So typically we build it pieces at a time. So I know I want to see the customer information for where those statuses are not shipped. But for now, let's just see if this even works. So I'm gonna hit that execute again. And oh, good. Oh no, not good. In the select statement here, we specified, hey, give me order number, status, and customer number. But wait, which customer number? Yes, I understand the fields have a relationship, but specifically, do you want the order number, the customer number from the orders table, from the customer table? You got to specify. It's ambiguous. It doesn't know which one it wants, so it's just not going to execute, right? That's the big difference between Excel and SQL, right? That's that asset that you'll learn about. If it isn't perfect, it's just not going to run. It's not going to attempt to figure something out. Maybe you meant this. No, you have to be direct and perfect with it. If you want a perfect system, you need something that's going to expect perfection. So that customer number is going to go, I don't know which customer number you want. Maybe it's not a big deal, right? But we have to specify that that customer number comes from a certain table. And in our certain instance, it really doesn't matter, right? But still, we have to specify. Now, do I have to type out the whole classic models.orders? No, not again. That alias will work up here too. Even though I specified it later, it'll still work here whenever it compiles. There we go. We have a result 3. There's more than 100 rows, right? But remember, I said just defaults 200. And we can see the order number. We don't see the dates, right? Because I didn't select those dates. I said only don't include those dates in the query. So the dates that used to go after order number, they're not here. So we have the status, just as we wanted. The customer number, oh, there it is. Customer name, first name, last name, whatever else we wanted. Maybe you put in phone numbers in there. And then there you have a list of people to call or emails. Now you have an email list. But I don't want to email all my customers. I want to email just the ones where, hey, dude, you were ordered and shipped. What's going on? Why'd you cancel it? Why did it have an issue? So I can say where, and that status field again. Orders table status. This time I'll use that operator. Same thing as the boom equals, which means does not equal. Same thing again, status. Or I'm sorry, shipped. Execute. Generally, SQL is not case sensitive. And there we go. Now we have those same 23 rows. Remember from that second result where I said, hey, just give me orders with shipped? I had those same 23 rows. So we didn't create any new data. We didn't add any more rows. We just added on some more information. All right, let's get a little bit more advanced. Some things you may want to know for the murder mystery. I'll be quick about this because I know we were running a little late. The select statement can have more than just columns in it. You can apply aggregations or functions to it. An example of that, usually the easiest one, is a count. So let's do this. Let's say count, or let's do select from, we're going to do the orders table, find me status, comma, and this time we're just going to type count with the parentheses. Most functions in SQL work like this, where it's the keyword and then the parentheses. Some programming language, it's backwards, but here that. And what do we want to count? We can say just count everything, but maybe we want to say count the order numbers. We can sometimes specify a field, count the order numbers from orders. We can just run that and see, hey, how many orders do I have at all? Go away, pop up. Status count order numbers. Oh, sorry. If you apply an aggregation to it, what does that mean, right? So you just said select this entire column status and the count. Well, the count isn't going to have a row for every column, right? So you need to tell it, hey, group by something. So the reason I put statuses in there, because I want to see the count for each type of status. So we're going to put in a group by. And we're going to say status, that other column I selected. Oh yeah, now we got it. So what it did here is went through there, and if it's right, it knew that the word canceled repeated in every comment that those really were the same. So it grouped them all together and then returned to me the count of order numbers. So the number of rows. Let's say select, I want to say select star from customers. Execute that just to make sure it works. I see all my customers. Cool. Okay, so this customer name is a little confusing because they're really business names, but that's okay. But I'm kind of curious. I need to find all of my customer names where it ends with co. That's all of the customers I'm interested in. I want to market specifically to them or something. If we're doing murder mystery, my murderer worked at a company. Let's figure out who it is. How can I filter off of just the CO if it's a part of a bigger string? It could be anywhere. I mean, this one, it's whatever, 12 spaces in. This one's more. How can I tell it, hey, just give me any, filter the rows to wherever the word CO period exists at the end of it? I need another wildcard, just like I used the wildcard of a star here to give me any columns. I need a wildcard for within the string statement. So we're filtering. So there's our where statement. I want to filter on the customer name column. So give me that customer name. And I'm going to use a different keyword. I'm going to use like. For each of the things, wherever things are like this string. Again, it's a string, so quotation marks. But this time, I'm going to use the parentheses. Why did they choose this? I don't know. But I'm going to use the parentheses. This is the wild card. It says, give me anything at the very beginning. I want co specifically. I'm going to end it. So anything, any amount, any letter, any number, anything that's a string for however long it can be, can exist in place of that wildcard, as long as it has CO period at the end and nothing after it, because it did not put a wildcard at the end. It's going to just filter it to that. There we go. There is my 26 companies, all of them that end with CO period. It's not case sensitive. So using all the things you learned here today will be very helpful in getting the murder mystery right and succeeding at that, and just good in general.